Okay, welcome to the notes for Math 31, Section 8.3, and this will be a two-part series. I'm going to do area first, and then I'll do volume and surface area, the three-dimensional shapes, on the second video. Okay, each of these boxes on the first page here has a separate formula, and you have to learn the shape values. This first one is a rectangle. And the area of a rectangle is very simple. You take the length times the width, and it'll give you the area. So in this case, it's going to be 6 times 14, which is 84. And the units for area are always square units, and you read it square feet. Back when we used to write it SQ period, FT period, nobody got it mixed up. I hear a lot of times people say feet squared here, and that's the wrong way to say it. It's square feet. Area is always square units, so square miles, square inches, square whatever the unit of length is in the problem. Okay, the next one is a square, and in this case it's a square with a side length of 9. So it's very simple. You just take that side length and you square it. And actually that's where that little second power gets its name, is from this problem. So 9 times 9 is 81. And that's 81 not miles, which would be length or distance. It's 81 square miles, which are the units for area. A square mile would be the area found in a square that's 1 mile by 1 mile. And that one had 81 of those, so it's a really big area. Okay, so the next one here is the area formula for a triangle. And you take the base length and the height. Notice that the height is not one of the original sides of the triangle. And you multiply them together, BH, and take half of that. So it's 1/2 times B times H. And here I'm just going to tell you the different options as far as how you can think about this, calculating it. You can multiply 1/2 times 18, which would be 9. 9 times 12 would give your answer. Or you can take 18 times 12 and later take half of that. Or you can even take half of the 12, which is 6, and 6 times 18 would also give the right answer. You just don't want to take half of both of them. This is not a distributed property problem. Okay, so that turns out to be 108 square centimeters. Okay, the next shape is a parallelogram. And the parallelogram has parallel sides in one direction and parallel sides in the other direction. So that's where it gets its name, parallel in both directions. And in this case, it's just the base times the height. And the height and the base must always be at 90 degrees. So you can see the base across the bottom there, and the height is just straight up and down. You got to make sure that you have a 90-degree corner between those two, the base and the height. Okay, so the next thing I'm going to do is just multiply base times height, 9 times 16. That turns out to be 144. The units of area are square meters. A square meter would be a large poster size. If you think of a square that's got a little more than a yard on each side, that would be about the amount of area of a square meter, and this one has 144 of those areas. Okay, the most complicated one in this list here is a trapezoid. And a trapezoid is identifiable by having two sides that are parallel to each other and two sides that are non-parallel. And what we have in this one is the two parallel sides are called the bases, base 1 and base 2. And this book that you have calls it little b plus big B, and I don't like that because it's just so unique to this author, and you probably don't want to do that. So anyway, b sub 1 and b sub 2. And because of the parentheses in the formula, that has to be done first, the addition. So you add those two lengths, 8 and 12, and then you multiply that by half of the height. Okay, so let's show you what this looks like. You plug all the numbers in. And before I go on, I want to highlight something here. The height and the base have to be at 90 degrees. Okay, and then you're going to add the 8 and the 12 before you do anything else. And probably the easier way to do this one would not be to take half of the 7. That'll give a decimal number. It'd be take half of the 20, and that would give 10. 10 times 7 is 70. So this one is 70 square yards of area. Okay, the circle is the last shape that I'll be teaching you. And the circle has a formula of pi r squared. We'll be using 3.14 as our approximation of pi. And when you do this, you're going to make sure that after you've plugged in the radius here of 6, by the way, the radius should always stretch from the center of the circle to the outside of the circle. If they give you the diameter, which would be all the way across, this problem would have a diameter of 12, for instance. You have to cut it in half before you use it in the formula because it calls for the radius right there. So make sure you're plugging the radius length in. Anyway, the squaring has to be done first, so you'll go 6 times 6 there, and then multiply that by 3.14, and you come out with 113.04, and anytime you're using an estimate like this for pi, you got to put a little dot above the equal sign to indicate that you rounded or estimated or approximated. Okay, the next page here is the same types of problems. I just don't identify them for you. So you have to look on the front page if you want to see the formula to use, but I've got them all printed here so you'll be able to see them. The rectangle has a formula of length times width, so just 8 times 11 here. And your units in this one are square kilometers. Again, don't read it kilometers squared. That's wrong. It's an adjective, square, and a noun, kilometer. And in English, we put the adjective in front of the noun. We say blue house, not house blue. Okay, find the area of this square, and the formula is, for square is the side length squared. So it's going to be 14 times itself, which is 196. And here the units of length are meters, so the units of area are square meters. This is a triangle, so we write down the formula. The formula tells us what we need to find. We need the base length, which is at 10. And this has an external altitude or height. You remember that I said that they have to be 90 degrees to each other? That's why I had to draw it outside, because this angle right here is not a 90 degree corner, and neither is this corner here a 90 degree corner. So those two sides are not actually the altitude or the height. So 1/2 times 10 times 12. And I'm going to take 1/2 of the 12, which is 6. 6 times 10 is 60. So this has 60 square inches of area. A square inch of area, 1 inch by 1 inch square, would be about a big postage stamp, a really fancy postage stamp. Maybe from, I think when I used to stamp collect, there was a country in Europe, Hungary, that used really beautiful big stamps. And a square inch is about the size of one of the ones I used to collect from that country. Okay, find the area of this parallelogram. It's just simply the base times the height, so 5 times 6. And I'm going to take the opportunity again to tell you that this base and this height have to form a 90 degree corner. They can't be at any other angle in order to qualify as the right values. So 5 times 6 is 30, so 30 square centimeters of area. Okay, we've got 4 more examples here. This trapezoid, here's the formula. The bases, the parallel sides are 7 and 11, and the height is 3. You have to do the parentheses first. And finally, a half of 3 would be inconvenient, so I'll take half of 18. 9 times the 3 we haven't used is 27 square inches. Now, if you just type this on your calculator using the parentheses, it'll pop out that 27. You'll get the right answer if you just type it on your calculator. Okay, 22 feet here, and this is all the way across the circle. So when I see the formula, which is pi r squared for this circle, that area formula uses the radius. I have to cut that 22 in half before it's useful to me. So that's where the 11 comes from. And squaring goes first in the order of operations, so 11 times 11, and then multiply that by 3.14, and that 3.14 is just an estimate, so we're going to put a little dot above the equal sign, indicating rounding or estimating or approximation. Okay, so what we have in this next problem is a little more complicated. It's a composite figure. What we have is a trapezoid on top. I'll call that area number 1, and a rectangle on the bottom, area number 2. So let's find the more difficult one first, the area number 1, and it's trapezoid 1/2 times the height times the sum of the bases. So we're going to have 1/2, and to get the height, you have to take advantage of the 14 for the total height and the 8 for the lower section. 14 minus 8 is 6, so I know the height is 6. That would be from here to here. And the bases are 16 and 10. So that's going to be 3 on the outside and 26 on the inside. And that'll be 78 square yards of area in that top section. Now the bottom section is just 16 times 8, which is 128 square yards. And so if we take 78 and 128, we get a 206 A1 plus A2. Total area of 206 square yards of area. Okay, on this last one here, it's not the last one of the notes, but it's the last one I'll do on this video here. We're going to cut this thing across like that and call the top rectangle A1, area number 1, and area number 2. Area number 1 is actually pretty easy here. It's just a rectangle that's 5 by 20. So that's 100 square inches of area. Okay, now area 2 is a little more difficult only because we have to work for at least one of the dimensions. You can see it's 7 in one dimension. It's printed there. But the other dimension we have to think about for a minute here. And the way to think about it is all the way across is 20, and the left-hand side is 6, which would make this right-hand side 14. So we end up here with 7 by 14, which is 98 square inches. And when you add A1 and A2, those numbers add up to 198. A1 and area 1 and area 2 add up to a total of 198 square inches. Okay, we'll pick this up on the other side. There's I think 2 more pages of notes here, and it's all about 3-dimensional shapes, so it's a little more difficult. We're going to be looking at the volume, how much something holds if it's a 3-dimensional object, and then we're going to find out the area on the outside surface, called surface area. And I'll pick that up in the second video.